want to divide rational expressions, we really just need to go back and remember how we divide fractions. And remember, a rational expression is really just the more general term for a fraction. So if I ask you how do you divide 6/5 divided by 18 over 25, the short answer is you're really doing multiplication by the reciprocal of the second fraction. So I'm going to turn this into a multiplication problem, leave the first one alone. I'm going to still leave that as 6/5, okay? And then I'm going to flip over the second one, and if you remember, we did this cross-canceling before where we factored the fractions and look for things that cancel. So I'm going to do that as I go. I'm going to take 25 and say 25 is 5 times 5. And when I put the 25 in my new multiplication problem, it is now the numerator because I'm taking a reciprocal. So the same thing's going to happen with 18. 18 is 6 times 3. Right? And I did that because I noticed there was a 6 over here as well. So I actually did two things at the same time. I did my factoring so I could do my cross-canceling, and I flipped it over at the same time. So this is really 25 over 18 instead of 18 over 25, but I put it in its factored form. So this allows me to do some canceling. Right? I can get rid of the 5s, and I can get rid of the 6s, and it looks like I'm just left with 5 over 3. And so the answer to their division problem, 6/5 divided by 18 over 25, is the fraction 5/3. So what we're going to do is the same thing, okay, but we're going to do it with division problem. So let me get down to my division problem. Here it is. Okay, and so remember, I'm just reminding you to divide. You're just going to multiply by the reciprocal, which means we're going to leave the first fraction alone. I'm going to just say this is x squared minus 8x plus 12. We're going to put it in its factored form. How do I factor things that multiply to 12 add up to -8? Well, that would be -6, okay, and -2. The bottom, and the denominator of our fraction also factors. This is x plus 2 and x minus 2. Remember, using your difference of squares, right? And I want to change this to a multiplication problem, but I'm going to multiply by the reciprocal of the second fraction. So when I look at the denominator of this one, let's just come off to the side because this is a 2 steps of factoring problem. I'm going to GCF out my 2, and it becomes 4x plus 4. And then I'm noticing that 2 times 2 is 4. 2 plus 2 is also 4. So this is going to factor one more time into 2, x plus 2, and x plus 2, right? And notice that that was the denominator in my division problem. It became the numerator once I took the reciprocal. And then I can take the numerator, which is x squared minus 9x plus 18, and remember that factors into x minus 6 and x minus 3, and that was the numerator. I've switched it now, it's the denominator. From here on out, it's just a multiplication problem. I'm going to cancel what cancels, x minus 6 and x minus 6. I have an x minus 2 and an x minus 2. I have an x plus 2 and an x plus 2. And it looks like I'm done. So I'm going to gather up everything that's left over. 2 and x plus 2 are stuck on the top. We did not cancel those. Okay, and I have an x minus 3 on the bottom. Okay, now here's one extra little catch that we have to take into account. We're going to state our domain restrictions. So if I look across the bottom of the fraction here, it looks like -2 and +2. So I'm going to write that as x is not allowed to be equal to plus or minus 2. Okay? The 6 from x minus 6, that's a domain restriction. And the 3 from x minus 3, that is a domain restriction. Now here's the catch. When we do domain restrictions, we have to tell people not to use any values that existed anywhere in the denominator at any point during the problem. So here's where it gets a little bit tricky. In my original problem, before I took the reciprocal, this one, I actually had 2x squared plus 8x plus 8 in the denominator. In my form that I just checked, that's up here, right? That's my numerator. So I actually need to look at this as well and say, all right, 2 doesn't contribute anything. It doesn't have any variables. This is -2. I did take care of that already. I have a -2. And this is a -2 as well, which again, we just said we already took care of. But I at least have to check. So I actually have to check, if I'm going to make a little list, this part of the fraction, that's a denominator. This part of the fraction, that's a denominator. And in the original problem, this third one now was also a denominator. So I need to make sure that I check that as well. In this particular example, it didn't contribute anything new to the problem, but we do need to check and make sure that that's not going to be an issue. Anywhere that there's a denominator, we need to make sure we restrict the domain for those values. So just be careful with that. It's a tricky little thing. We'll see that show up more. Okay, so that's one type of division. I want to show you a couple of other little tricks that might show up. So here's your second problem. Okay, so again, I'm showing you a number problem on the right to compare with our rational expression algebra problem. On the right hand side, I have this fraction one on the left. So here's what I want to remind you. This symbol right here, the fraction bar, really means the same thing as the division symbol. So if I get what's called a complex fraction or an improper fraction, meaning that I have things that are not whole numbers in the numerator and the denominator, what I can do is I can rewrite this as 2/3 divided by 6/5. And then I can proceed as we just did in the regular problem. So I'm not going to go through and do this one, but I can take the reciprocal of 6/5, cross cancel, and I can complete my problem. Okay? But the big idea here is that this division symbol really just means the same thing as the fraction bar. They're interchangeable ideas. So for this second example, we will do it. So I'm going to rewrite this as 6x minus 2 over 8x plus 1. That was the numerator. And I'm dividing this by the denominator, which is 9x squared. Okay, minus 1 over negative 3x minus 1. And now I can treat this just like I did the last problem that we went through together. So I'm going to look at this and say 6x minus 2. Well, that is the same as 2 times 3x minus 1. That's got a GCF. Okay, 8x plus 1 does not have any common factors, and it's a linear binomial, so it's not going to factor anymore. I'd like to turn this now into a multiplication problem, but I'm going to multiply by the reciprocal. So that means that this negative 3x plus 1 is going to come to the top as negative 3 times x plus 1. So I am going to pull out the common negative sign because that's going to help me. You'll see that in a second. Okay, and then 9x squared minus 1, which was the numerator here, is going to become 3x plus 1 and 3x minus 1 using my difference of squares rule. Right? So now I'm going to do my canceling. Okay, and it looks like I have a 3x minus 1 with a 3x minus 1. I have a 3x plus 1 with a 3x plus 1. And what I'm going to do here, just to make sure that we're clear, this negative is really negative 1. So I'm just going to write that instead of just have a negative sign hanging there. It makes it a little bit more clear. So now let's take a look at what I have. On the top, 2 times negative 1 is negative 2. And in the denominator, I have 8x plus 1. Okay. So again, I got to state my domain restrictions. It looks like negative 1/8 is restricted. Right, and that's what happens when I set 8x plus 1 equal to 0. And then also plus and minus 1/3, which come from negative 1/3 and positive 1/3 in the denominator here. When I look at my extra term that I had to check, this 3x plus 1 also gives me a negative 1/3. So I have nothing new to worry about there. But I just had to check again to make sure that there was nothing additional that I needed to contribute. Right, so you get the idea here. Division is not really anything new than what you learned when you learned how to multiply with fractions. Dividing by fractions is multiplying by the reciprocal, and if I get one of these improper fractions, we're just going to turn them into a left to right problem with the division symbol in between instead of a fraction bar.